and that is Sander van der Leeuw from Arizona State University, who is going to talk about an archaeological perspective on environmental change. And Sander is one of the members of the new project, which not many of you may have heard of, called IHOPE, which stands for Integrated History and Future of Peoples on Earth. And this is a joint initiative between IGP and IHDP. And I'm sure Sander's going to mention some of that now.
It's on great. All right. What I'm going to do is, after admiring over the last 3 talks how much on the basis of your environmental data you have got to know on the behavior of that system and what the implications are for the management of that system, I'm going to completely shift and move towards how the long term of the archaeology and the paleoecology together can actually get us to understand more about the human part of the behavior that is involved in this system. This just summarizes, and I'm going to go rather fast through quite a few of the slides because we're so late. But this sort of summarized some of the reasons why we wanted to do this long-term research. And essentially it is that much of our governments and international institutions are now working on models to predict our future, which don't take much more than about 50 or maybe 100 years into account. And I have summarized here some of the things that you miss in that case. You miss all the slow dynamics. You miss the change of change, how actually in particular in society but also in the environment, the dynamics themselves change. And you also begin to look at a recent situation which actually is a little bit like looking at a very ill patient without knowing what a healthy person actually looks like. And those things have driven us in the early 90s at the request of the European Union to begin a piece of research that looked at the long term of modern environmental problems in the Mediterranean. Now, I'm going to only take one very small part of that project to illustrate you some of what I want to say. This summarizes the project, basically trying to get the advantage of archaeology in looking at long and slow processes combined with the advantage of looking at the modern period where you actually can fill in a lot of the more rapid dynamics so that you can begin together to get a composite image of what all the various temporal change scales do and how they interact. These black dots are areas where we worked. I'm not going to go into any one except for the one that is not a black dot, and that is a sort of vertical rectangle, the southern Rhone Valley, because my example, and I'm only going to use one, is from that area. This is a little bit of a closer image of that area. The color comes across a little bit different than I had expected, in particular at the end, at the right-hand side. The green areas are actually our sample areas within this region. The main picture shows why this area is important. It actually has a very interesting interaction between 2 climates, the Mediterranean and the Alpine. And that is one of the reasons for taking this particular area and considering it. This summarizes some of the kinds of dynamics that we actually found over a period of the whole of the Holocene. And what is interesting, if I summarize this whole slide in a couple of sentences, is that whereas at the beginning of that period, there is very little dynamic that you can see in the landscape unless it is driven by climate. In the middle, you begin to see an interaction between climate dynamics and human dynamics, and that interaction is actually quite a complex one, and I cannot go into all of that in this particular talk. Towards the end, those 2 components of the system have become so hyper-coherent that the slightest variation in either one, either the human part of the system or the climate system, actually has major impact on the landscape. And I think that is one of those things that a long-term perspective can teach us, is what the effects are and what the causes are of that hypercoherence. Now, in this particular talk, I'm going to have to focus on only one of the cycles in that, which is the Roman period from about 800 BC, which is taking it large, but that is necessary for the talk, till about 600 AD. One other element in this, one of the interesting things in looking at this is that we often talk about environmental degradation. And we were able to find here 5 completely different reasons and ways for the degradation of that landscape, which each occurred at different periods during that stretch of 10,000 years. This graph it's difficult to read, but essentially all the upper graphs, the red line near the bottom and everything that is above it, are actually signals of global climate change, whether they come from the Arctic poles or the Antarctic, or whether they come from hydrology in the area in Europe. But the one that is really interesting here is the one that comes from the area that we're working in, which is the very lowest, where you see lots of ups and downs, and then suddenly a red peak. And that red peak is actually smack in the Roman period. And what does it show? That we actually have an environmental degradation there, which is not correlated in any way with any climate degradation. And what we argue is that this is a first instance of a macro-regional anthropogenic degradation in that particular part of the world. And one of the reasons for it, and I'll come back to that in a moment, is that the Romans, as soon as they colonize this part of the world, institute a kind of agro-industry which has very, very detrimental effects. Reasons for studying the Roman period. Some of those are that we have extraordinary data, we have archaeology, we have written data, we have actually a map of part of the area made in Roman times. But there are other reasons. When the European Union asked us to do this piece of research, there was sort of a climate of, a feeling of crisis, and that has not gone away. So what we looked for is a period that the people in the period itself had also experienced as a crisis. And there is a lot of literature in the Roman period debating whether that is actually an environmental crisis or whether that is not an environmental crisis, but a political one or a demographic one or yet another one. And that was another major reason. But there are other reasons, and I will summarize most of those that are on the lowest part of this slide by essentially saying that the Romans have a very particular, very administrative view of how to manage a landscape. And it's most symbolized that in the area where we are working, we see exactly the same sort of square land divisions that you see in large parts of the US West when you fly over it. And here, they're generally roads. There, they're generally drainage ditches. But I will show you at the end of this talk that in neither case are they very adapted to the landscape. And there's other phenomena in there, the land reallotments, the aqueducts, and things like that, that make the Roman system actually quite similar to our own. This is the progress of settlement across the area that we're dealing with, and it goes from the heaviest line in the map on the right-hand side to the thinnest line in periods of 50 years. The black graph shows essentially in the upper part that there is a very rapid increase in new settlement between the second half of the 1st century BC and the end of the 2nd century AD. The lower part of that graph shows that although there is no new settlement coming up after the second part of the 2nd century AD, a lot of the settlement continues to be used. Now, an interesting part of that is if you look at that against climate, you begin to see that it's totally independent from the actual climate variations that we observe in the area. Because the green areas are sort of mixed areas from a climate perspective. The blue ones are unstable and the yellow ones are stable. And as you can see, that whole settlement pattern goes across all those different phases and is essentially socially driven rather than environmentally impacted. Now, we did a lot of analyses that brought together the landscape itself and its different units, the vegetation, the exposure to the sun, and various elements like that. A lot of the talks that you've heard this morning have actually gone over some of the similar domains, and I've actually cut those out of this talk to be able to move on to what are the important parts of the human aspects. And what this slide shows is a very interesting thing in that, okay, normally speaking, the landscape in the sense of mountains and where there are valleys and things like that is relatively invariable over the 2,000 years that we're talking about. What is completely variable is the actual perception of the soils. And so we used the texts of the Roman agronomers to come up with the categories of soil perception that the Romans used themselves in order to redraw the soil maps that we had for the area in order to get a better understanding of why particular choices were made in settlements. And this shows on the left-hand side simply the redrawn map. On the right-hand side, the little rectangles, and because the slide projection is a little bit fuzzy, it doesn't show very easily, but the numbers in there are actually the tax rates that we have from the Roman map. And so we can argue there that there is a reasonable degree of convergence between the soil qualifications that we have distilled from the agronomers and the actual tax rates that are being assessed in that particular area. Now, if you go to settlement from there, the crucial element to realize is that a settlement is the result of a landscape choice at the time that that landscape was being colonized. And so what we begin to do, and what we did, but I haven't got a whole bunch of slides of it, is actually on the basis of about 1,000 settlements in this particular part of the world, analyze what the preferences are of the Romans for settlement in particular parts of the landscape. And that was, this is this slide. I hope it stays on there, yes. What you see here is through time, from 800 BC to about 800 AD, how people changed their choices of where they were actually going to implant their settlements. And essentially what it boils down to is that the classification of the soils teaches us that the Romans are not particularly concerned with mineral content or drainage or things like that, but that their preference is actually easily plowable and workable, sandy, mobile soils. That is why they begin, usually, to settle on lower hill slopes, facing south and later east and a little bit more west. From there, you begin to see first a move upward into the landscape, and then when there is no more place there, they actually settle down in the river valley, which we would now consider the most fertile part of the whole region. This simply shows you how that relates to exploitation. What I have on the lower part of this graph is a number of, let's say, dominance or decrease of particular kinds of vegetation. The upper half of that graph essentially shows what the settlement peak is like that I showed you earlier on. I have to go very fast through a number of these categories because I overlooked trying to summarize this in one graph. But essentially what we, oops, and now I go too fast. Boy, that goes. Essentially what this boils down to, I've taken the second slide, is that you have two modes of exploitation, one in the highlands and one in the lowlands. And we can measure the intensity of exploitation in the highlands by measuring the eroded surfaces in those highlands. And down in the lowlands, we can actually measure the extent of the agricultural lands in the lowlands. And if you compare those two curves, you can see that there is a very direct interaction between those two. And this is this moving up and moving down of people in the landscape as a result in part of climate and in part of human impact. Yeah, that's fine. Okay, this shows a very simple set of slots that shows you how, on the basis of some of these dynamics, we actually predicted where in the next 50 years the next lot of settlements was actually going to land in the landscape. And then to say something about the environmentalness of this crisis, the left-hand graph simply gives per sort of region and therefore per kind of landscape the duration of settlement. If you look on the right-hand side and you look at it proportionately, what comes out of that is that notwithstanding the kind of landscape these settlements are in, most of them actually survive for about 2 centuries and then it's finished. Now that independence from the landscape argues to me that the actual transformation that we see in the 2nd and 3rd century is essentially driven by the economy and the politics rather than the climate. And that was a completely novel sort of explanation for what is happening in this area. Some of that is summarized in this graph, where you actually see the relationship between major and minor settlements and how that evolves over about 10 centuries. At the beginning, you see some small settlements, some large settlements, lots of small settlements, and the large settlements draw upon the small settlements to actually get their economic system and keep it going. By the 5th century, you see that the hierarchy in settlement size has been reduced substantively and that settlements are actually more and more independent. The 11th century picture is there to show that after the 5th century there is a breakdown in the Roman system and that in the 11th century a completely new and different settlement system actually emerges. A last interesting case is in this particular area where the Romans in the 1st century BC start this very large drainage project to actually pension off their soldiers. And by the time that the civil wars end around 0, there aren't enough soldiers anymore, so you can't keep that drainage system going. So immediately the natural drainage system, which is sort of northeast, southwest, takes over again. And it shows sort of the vainness of sort of imposing the kind of administrative structure on the landscape that the Romans tried to maintain, which is so energy consuming that it just can't work in the longer term. The crisis of the 2nd and 3rd century was overcome. That of the 6th century was not. It is the end of the Roman Empire. You begin to wonder why. And one of the reasons that you can argue, I think, very cogently, is on the one hand that the system has become much more hypercoherent. Secondly, that it has no longer any easy pickings of wealth that were accumulated before the Romans invaded all these areas. And so they are now dependent totally, essentially on solar energy annually to maintain their economy, whereas their administrative system has become so much heavier in the way of overhead that they can no longer do it. So there is no longer an advantage for people to actually abide by the Roman rules. And so people start dispersing, start founding their own little statelets and things like that. What you see through the long-term time, therefore, is what I've called, borrowing from Tim Ingold, the appropriation of nature, in which the landscape, initially driven by the natural dynamic, becomes essentially maintained by the human interventions in that landscape. And that is that kind of hypercoherence that I've argued in the beginning, which essentially leads to the fact that an accident is waiting to happen. Now, some of that is to do with the fact that in human interaction with the environment, we have this interesting interaction between seeing ourselves at the center of the environment or seeing it in the reverse perspective. And in French, you can actually symbolize that by taking milieu on the one hand and environment on the other. If you look at some of the ideas that the Stanford School has developed on how you assess risk under conditions of uncertainty, you come to the interesting conclusion that those two perceptions are like a tangled hierarchy that ultimately drives us further and further into intervening in the environment, thinking that we're doing it to avoid risk, but building up risk instead. Part of that is that as we are working in that environment, we do things in it, we thereby mitigate the frequent risks that there are in that environment, and instead we actually build up long-term risks that we don't know and that lead us to the kind of time bombs that we're confronted to at the present time. And that then leads me to begin to philosophize a little bit about crises. And I think one of the interesting things to do here is to not see a crisis as something that comes from the outside, but simply see it as a temporary incapacity of the society to deal with the kinds of things it needs to deal with if it is to survive. And if you work from that perspective, you begin to doubt how reversible those kinds of dynamics actually are. These are some of the basic conclusions. Long-term is important. Multi-scalar approach is essential. You need to focus on society as the actual driver in this, because it is us who define what our environment is and what we see in the environment, what its problems are and how we might deal with them. So it is not enough to look at the environment from the outside and look how it impacts on human beings, but you also need to do the reverse. And in particular, that impact is strongest where it is most dependent on the environment. I skipped one more. These are some of the impacts for research policy, multidisciplinarity, much better data management and mining, an increased role for the social sciences, a serious doubt whether we have enough time to actually do all of this, and a very great emphasis on education as an essential part of it. In the causalities, the core research issues are: what role does society actually play? What kind of future do we want, rather than what kind of future don't we want, which is how we are now dealing with sustainability, because we are basically saying, well, we had a comfortable lifestyle, how can we keep it? That is not the way this can go. How can you translate the lessons from the past into the future? I have given a little bit of an example, but there are huge epistemological problems in actually doing that. And then the last question is, can we avoid a crisis? Now, last slide, I hope, is this new project where we're trying to do for a number of cultures the same thing that I've tried to show you for this particular part of France. And to take the cultures of the Southwestern United States, the Maya area, the Peruvian area, and a number of major culture areas to begin to look at a scale of at least 1.5 millennia, if not 2 or 3 millennia, how those interactions actually transform both the culture and the environment. And that is what I want to simply urge people who are interested in this to come and see either John or myself, because we are looking right now to mobilize a bigger community to begin to deal with those kinds of issues. And to get you a little bit of the flavor of that, and because somebody else did it too, as a last slide, I make a publicity for the book that came out of it.
Thank you, Sander. Is there any one quick question? Yep, over here. Yeah, you can meet in the middle. Great.
You showed me that they were selecting a particular type of soil for their agriculture purpose.
Yeah.
Was that because of they were they were used to a particular type of crop they've chosen. So that soil was suitable to grow that crop, and that's a possibility, not that they were not using other type of soil.
Well, let me sort of, the system as a whole is actually only using 4 or 5 major crops over any surfaces as concerned. Olives, vines, cereals, and some legumes. However, the big difference between the Roman system and our system is that they had no mechanical ways to plow those very heavy soils in the river valleys. And so they chose, with the ard that they began with, because the actual plow that turns over soil is being discovered in the middle of this period, people actually began with those sandy soils that were easier to cultivate. But there is no change in the crops that are being cultivated throughout the period, even though people start using different soils.